Hello, chemistry students. It's Mr. Laudermouth, and I'm back this time with the third and last of our 3 Unit 2 gas labs that are helping us to understand learning target number 4. And in this lab, we are trying to answer the question, what happens to the pressure of a gas when its temperature doubles, triples, and is cut in half? Last 2 labs, we examined the effect of volume and then the effect of number of particles, which we call puffs, on the pressure of a gas, and we saw some interesting relationships there. In this case, we're going to do a similar procedure involving change in temperature. We're still going to GAM trib. We want to graphically and mathematically model the relationship, this time between the gas's temperature and its pressure. Once again, I'm going to need a LabQuest, and I'm going to need a gas pressure sensor. But I'm going to show you my LabQuest screen because once again I have this hooked up to my laptop. Yes, we're recording pressure just like we did the last 2 times in millimeters of mercury, but notice I'm also recording temperature. That's because, and I'll show you real quick, I have this. This is a temperature probe. Basically, it's just a fancy thermometer that attaches to the LabQuest and can tell us the temperature of a liquid or a gas or whatever temperature we want to find. Why would I care about that? Well, remember, we're supposed to be looking at the effect of temperature on pressure, right? So temperature is going to have to be something I need to record. So going back to this screen, it also says we're going to need a flask, a water bath, ice, and a hot plate. So here is my flask, which I've already attached to my gas pressure sensor. So this flask is totally empty except that it's got air in it. This is a 50 milliliter flask, so it's got roughly 50 milliliters of air in it, probably a little bit more than that. And it's connected by this plastic tube to our gas pressure sensor. No syringe this time because what I want to do, the reason I'm keeping my gas in this flask is I want to be able to conveniently change its temperature. And the way to do that is with a water bath. So what I've started with here, I've got a 400 milliliter flask, and in it I've put some water and ice. So I'm going to start at a cold temperature. So I'm going to go ahead and stick my flask, you can see that, down into my water bath, and let that start chilling. And I'm also going to put in my temperature probe so that we can record the temperature. I'm going to let that go for a couple minutes. I don't want to record any data yet until I know that the flask is at the same temperature as the water bath. Hopefully that makes sense to you. But we do have a job to do. Let's finish reading the rest of the directions. It says record the pressure and temperature for at least 5 data points. At least 5. I put in a bigger data table in case I want to get more data. With a 15 to 20 degrees Celsius gap between temperature readings. In this case, to make sure that I get decent data, that it can actually give me a useful graph, I don't want to have my temperatures stacked right on top of each other. I actually want to have a fairly good separation between temperatures when I record the temp and the pressure. Just like last time, we need to take a minute and think about what are the other variables that could change in this lab that we want to keep the same? Well, we're changing pressure, right? And we're changing temperature. So right off the bat, since we're not disconnecting this flask at any time, I'm never disconnecting that tube from the gas pressure sensor, I know that my number of particles has to be staying the same. There's whatever number of particles that are in there when I connected the flask to that plastic tube. Now that it's connected, I'm not going to take it apart again until the experiment's done, so the number of particles in there is not going to change. It's fixed. What's the other thing we could change? Well, if you think for a minute back why we used a syringe in that first lab, we used the syringe with the plunger so that we could change volume, right? But this time, I don't have a syringe. The size of that flask is not going to change. It's one size. It's never going to get bigger or smaller. So that tells me that the volume of my gas is always going to be the same. All right, should we get our first data point? It looks like the temperature and the pressure have stabilized. So I'm going to go over to my LabQuest screen. Right now we've got a temperature in the flask of 3.5 degrees Celsius and a pressure right around, we'll say 683. So we have 3.5 degrees Celsius. And we've got a pressure of about 683 mmHg. Okay, from here on out, I only want to go up in temperature. It would be difficult to keep going down. I could probably get a little closer to zero if I put in more ice. But that's a good low point. Let's get the temperature up higher. And for that, that's where my hot plate comes in. And I haven't shown you that. I would trust that you would take my word for it, but let's see if I can't carefully, without making a mess, turn my laptop around, and let's see, is that gonna work? There it is. So there's my hot plate, and right now, as we speak, it is set on about a medium heat. So what I'm gonna do right now, I'm going to take this flask that's still in my water bath, still connected to the pressure sensor, and the temperature probe's in there too. And I'm going to carefully set that right on my hot plate. Okay. And let me give you one more quick peek. All right. You can kind of see for yourself, there it is. So there, it's on the hot plate. I've got the temperature probe connected. I still have the gas pressure sensor connected. So what I want to do now, it's basically just a waiting game. I need to wait until the temperature goes up at least 15 degrees right before I can record any more pressure. So I'm going to join you again when we're ready to get our next piece of data. All right, I'm back. Let's take a look at our LabQuest screen. Temperature's definitely gone up. It's right at about 26.6 right now. And the pressure's at about 745, we'll say. So at 26.6 degrees Celsius, we've got a pressure of about 745 mmHg. All right. I'm going to keep this going now, and I'll see you again once I'm finished getting all of my data. All right, hi again. As you can see, I finished collecting data for this lab. I got additional data points at 42, 57, 73, and 90 degrees Celsius, and I filled in the corresponding pressures from the LabQuest. Just like the last two labs, I thought it might be a good idea to go ahead and make a real quick graph with this data, just to see if we can spot any relationships right now. So I went and did that. I'm going to pull that up. And this is what I got when I plotted gas pressure versus temperature. And again, I think we have a pretty clear relationship going on. As the temperature increased from, we started, I believe, at 3.5 degrees, up until 90, there's a very clear increase in the pressure. It goes up as temperature goes up. So let's jump back. And let's make a quick note of that. As the temperature of a gas increases, its pressure also increases. Of course, we again have to remind ourselves that relationship only holds when we hold the other variables, number of particles and volume, constant. If we keep volume and number of particles the same as we did in this lab, then yes, increasing a gas's temperature does increase its pressure. Okay, I'll see you next time. Bye.